Welcome to this tutorial on financial modeling using Kaluta projection methodology. Last time we introduced modified internal rate of return and explained why it is more accurate compared to traditional internal rate of return. Now we are going to introduce other two evaluation metrics, that is XNPV and XIRR, that are used to improve on traditional NPV and IRR. So let me create a sheet here and rename it and call it, say, XNPV. Okay. So NPV and IRR assume that the cash flow is timed at the end of regular time periods. Okay, so the cash flow should be regular and should occur at the end of the period. For XNPV and XIRR, there is no that requirement. The cash flow can occur any time, okay, and not necessarily on regular interval and not necessarily on at the end of the period. Okay, so that's why XNPV and XIRR are important valuation metrics, because you find situations where your expected future cash flow is not regular, and for that matter you need to use XNPV and XIRR. So let me demonstrate by using XNPV. Let's do it manually, compute XNPV manually. So say our project here, I put the start date for the project. When you write the date, it should be in date format, okay? Otherwise the XNPV formula and XIRR formula will not work. So it should be in date format. And for that matter, you either can use date formula, that is start with equal sign and then type date, this one on top, and then it shows you need to put year first. So year, in this case, say 2021. Month, I click on the month section there on top on the formula, and then say June. So say June, and day, say 19. Oh, sorry. In month here, instead of writing June, put 06. Okay. So you can use either this way, or you can simply, for example, the next date here, this is the start date, and the next date, say it is on September, so I start with 9 for the month. This is American style of dating. September 30, say, so comes date, and then and then comes year 2021. So I can type it that way instead of using date formula. The other, say on December 31st, 2021, and maybe let us take the last one here, and say it is March. So 3, start with 3, March 15, 2022. So let us assume that our project starts on June 19, 2021, and the cash outlay is related. I start with negative for the cash outlay. Say it is Tanzanian shillings 600,000. That is the outlay. And then on September we expect to get, say, 200,000. On December here we expect to get 500,000, say 400,000. And last year we expect to get, say, 200,000. Okay, so that is our expected cash flow. Now, as you can see, this pattern is not regular. Okay, one period for example here. Let me first put the days here, formula for the days, so that we understand better. So how many days from start date to start date is 0. So I put a formula there so that I can drag it. Start with equal sign. So let's assume this is the end date. So I click on the end date, and then minus start date. It is the same, but I need to lock this start date so that it is used with the rest of others when I drag the formula. So I start with a dollar sign, and it's type B, and again dollar sign, type 2 to lock both column and row. Press enter. Okay, so this one I can tap to fill to the rest of our. So you see, the next positive cash flow is expected after 103 days from the start period here. Okay, the next one is 195 days from the start period here, and so on. Okay, so you can see it is not regular pattern of timing of the cash flow. So you cannot use NPV formula, Excel NPV formula, to compute this NPV for this project because of its irregular cash flow. So actually what we are doing right now, we are computing XIRR. First we do it manually, and then we will use Excel formula. Of course, doing manually will enhance your knowledge of how exactly the inbuilt XIRR Excel formula works. Okay, so we need to put now the discounting factor of our cash flow. Discount factor. For XNPV and of course XIRR, the computation for discounting is done on 365 days, okay, instead of regular period, so that you can have, that means you can compute a discount on daily basis. Okay, so for discount factor here, I start with equal sign, open the bracket, 1 plus R. Okay, I will put the R here. I'm just I will put the R there. So 1 plus R, and then close the bracket to the power of N. And N in this case is actual days since the start of the project divided by 365. So actual days here for the start is 0. So I just pick this one. I pick this one. Okay, before that, let me put first, open the bracket, click on this one, and then divide by 365. 365. And then close the bracket. Okay? So that is the discount factor, and I can simply tap to fill this throughout. So, sorry, something is not right here. Okay, I didn't lock B1 here, so I need to lock this B1. So I start with $, then B, then $, again, then 1. Okay, press enter, and here I need to put the rate, which say it is 15% cost of capital. Press enter. So after that I can tap to fill this. Okay, so we have our discount factor to discount our expected cash flow and bring them to the present value. Okay, and you can see the formula has used N here is a percentage of a year. For this case, it is 103 days divided by 365 days. So it is a percentage of a total year. Since this, I mean, comparing the date when the actual case has been timed compared to the start date of the project. Okay, so that's how the discount factor has been established using 365 days in a year formula and using actual days on which a specific date on which you expect the cash flow to actualize. Okay, so after that, simply the PV now. The PV is simply the start with equal sign, the nominal value here multiply by, divide by, sorry, let me use this one, nominal value divide by discount factor. Press enter, tap to fill this to the rest. So XNPV, XNPV now is simply the summation of those present value. So that is, let us use this formula here, summation, sum these PVs, you get, press enter. So that is our XNPV. And let us now, this is manually computation, let us now put formula here for XNPV. So start with equal sign and then type XNPV, this one, I choose this. I'm now asked to put the rate is this one, so I click here, and then values, so I click on the values section there to select it, and then check these nominal values, and then click on date section to select it, and then pick from here to here for the dates, then press enter. So you can see the manually calculated XNPV is exactly the same as the XNPV calculated using the formula. Okay, so that is how you compute XNPV. And for XIRR, of course, manually here, you know, the IRR basically, it discounts the cash flows and bring them to the present value using the rate that will make NPV to be equal to 0. Okay, so that means you don't have IRR, you are not given, but you have to compute it, and that one uses iterative process. Okay, you can say, for example, you can have two assumption for NPV, for IRR. One assumption will give you negative sum of present value, and the other one will give you positive sum of present value. Then the IRR will be the break-even point between the negative figure and the positive figure. So you can use linear interpolation to compute the IRR. But we are not going to do this on this exercise because it's not necessary. After all, we use Excel to make our life easier, isn't it? So for XIRR, I'll just compute it by, so XIRR is equal to, start with equal sign, type XIRR, this one, I pick this one. So we start with values, and our values are these nominal values here. We pick them, and then I click on dates, and the dates are on top of our nominal values here. So I select them. Guess is actually, what do you guess to be the internal rate of return? Okay, so if you don't put it, Excel will automatically put 0.01 to be the guess, so no need to put it. So just press enter. Okay, so this is our XIRR. Let me put it in percentage form. Now, XIRR actually is an annual effective rate of your projected cash flows. Okay, so you need to know that when you use XIRR, the output is annual effective rate. This is important to know because when you compute periodic IRR for periodic cash flow, the rate is not annual, but it is periodic. Okay, the IRR for period. For example, if the periodic cash flow is monthly and you compute IRR for those periodic cash flow, then the IRR is monthly rate. But if you use XIRR, you are going to get annualized effective rate. So you should note that. Okay, so after doing that, then let us go to our projected cash flows here. So far we have assumed that we have calculated IRR and NPV. So if we use these to compute XIRR and XNPV, what we need now is to have, let's say in our computations here, we have discount factor. Okay, I'm not going to do it manually, I just want to use XIRR formula, and for that matter I need to assign dates for our unlevered free cash flow, which we used to make business valuation metrics. Okay, now as I said, the IRR and NPV assumes that the computation is based at the end of the period and at the end of the regular period. In this case, it's an annual. For example, from year 0 to year 1, year 3, there is annual period from one timing of the cash flow to the other, okay? And which means now the IRR and NPV assume that these expected cash flow appear at the end of the year. But if you look at our business modeling, we did our projections on monthly basis. Let's say, for example, let me go to P&L sheet here on monthly basis, okay? So we do our projections on monthly basis, and you can see profit before tax, for example, here. So our pattern for the expected sales and expected costs is normally distributed in this business model, okay? It's normally distributed. So we can say the cash flow appears normally distributed, not at the end of the period. If we want to exact our timing of our cash flow, we can say that our cash flows are normally distributed, and for that matter, we can use midpoint as our expected timing of the cash flow, okay? When we use a year, our yearly here. So starting from year 0, in this assumption, as I said, year 0 for us is that pre-operating period, that period when you haven't yet started to generate sales for your business. That is year 0. So for our modeling, year 0 covers January, February, and March. Starting from April, we start to generate sales. Sales start to be generated here in April. So year 1 starts from April. So for January, February, and March, we can assume the midpoint here is on February for year 0. So I go back, for year 0 is February. So let me go back to our annual cash flow there sheet. Annual cash flow here in this sheet. And then for this unlevered free cash flow, let me insert a row here. Insert row. So January, February, so it is February. So I put February. I just write February. February, that is 2022. Is the midpoint for year 0, okay? For year 1, let's go and see again in our monthly profit and loss statement. Year 1, in our case, starts from April and ends in March. Year 1 ends in March here. So the midpoint should be 6 months after April. So this is April is the first month, and then May 2nd, 3rd, 4th, 5th, 6th. So on September is the midpoint, September 22. So I go back to my annual cash flow. So here it is September. September 2022. So that is the midpoint. The midpoint. And this midpoint now, year 2 is going to be the same. And this one is going to be September 23. Okay? the midpoint, okay, the same. So I can September 23, let me type September 23, September 2023, and I can select these two and drag them to the end, fill them to the end of our just 1 year was left. Okay, year 3, this we are in monthly, yeah. So because we are in here, or in our, we put these estimates of midpoints in our annual cash flow. So we have used the midpoints to establish expected timing of our annual cash flows, okay, as midpoint. So we can use that then to compute our XNPV and XIRR. So in this case, we have IRR here, and we have NPV here, and maybe let me insert a row there, insert a row and call it XNPV. XNPV, which is going to be equal to, start with equal to, then type XNPV, XNPV, which one is this one? Rate is our, this one, weighted average cost of capital, so I pick this one. Values, I click on the values here and select these nominal values of unlevered free cash flow. This one from here, unlevered free cash flows, up to here. Dates, we are going to pick our mid dates, midpoint at the dates at midpoint of our normally distributed cash flow. Okay, so press enter. So that is our XNPV. Okay, so you see the XNPV is greater than the NPV. Why? Because XNPV assumes that the timing of the cash flow is at the end of the year, while in XNPV we have assumed that NPV assumed that the timing of the cash flow is at the end of the year, while XNPV we have assumed that the timing is at the midpoint. So for that matter, discounting something that at the end makes it more or less compared to discounting something at the midpoint of the end of the year. Okay, that's why our XNPV has become greater than our NPV. That's the explanation why we have greater NPV, and that's also explanation why XNPV is better compared to NPV, because it tries to enhance the correctness of our projected numbers or projected NPV. The IRR, again, I'm going to insert row below IRR and then type XIRR, XIRR. So start with equal sign, type XIRR, this one pick. So we are required to start with values, and our values again, these unlevered free cash flow, we select them up to year 3, and then click on the dates in the formula section and pick the dates which are on top of our projected unlevered free cash flow, and then guess, just leave it as I said, enter. So our XIRR in this case is 93%, which is greater than the IRR. Okay, and the reasons are the same. If you have XNPV greater than NPV, okay, so you should also expect XIRR to be greater than IRR for the same reason of the timing of the cash flow as I explained in NPV and XNPV situation. Okay, so that is how we used XNPV and IRR to compute the numbers basing on the assumptions of our projected business, which makes it more sense by assuming that our cash flow actualizes at the middle of our normally distributed expected cash flow. Okay, so let us end here. After this, the next tutorial, I think we should now introduce terminal value, and after terminal value we can now go back and do our valuation metrics on monthly basis, because right now we are doing these valuation metrics on annual basis. So because we have our projected numbers on monthly basis, we can also go and make our valuation on monthly basis, so that you see how that works. So that's the end of this tutorial. Subscribe to my channel so that you get posted whenever I share new content in this. Thanks for watching.